All right, hello everybody. This is Mr. Gable again. Here are the things that you're going to need. No shocker there. That kind of makes our learning a lot easier. Remember when you see this icon, which I think I have it on most slides, but make sure you're copying this work down. Today there's just a lot of stuff, so keep up with me. Pause this video, rewatch. Make sure that when we connect, if we can connect through any kind of hangout, that you ask any questions that you have about this math lesson. All right, our title for today is All Things Polygon, and today you will work to have a better understanding of how to calculate the interior and exterior angles of a polygon. Okay, so let's start with just some real quick thinking. Many road signs are polygons. Road signs are signs found along the road, like a stop sign. Try to come up with as many different road signs as you can and see if you can classify the polygons by the number of their sides. So take a minute to just think of some other than the stop sign that I just mentioned. You can include that one, and I'll see you on the next slide. So here are some signs that I collected. There's my stop sign. 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay, here's a bunch of other ones. Okay. And here's also one, a big billboard, large rectangle. So 4 sides there, okay? You see kind of, there's the triangle there with the yield sign. So a lot of different things that you can have. The number of sides is really important, okay? So let's talk about what makes a polygon a polygon. So really the list of things that makes a polygon are, first of all, poly always means many. Okay, and gon means angles. So it means simply a polygon means many angles. Now you see here there are pictures of polygons, and then these are not polygons. And I really love for you to just copy some of these shapes into your notebook. And then down here is our definition in purple. So a polygon is just a closed 2D shape. It's made of straight lines, not a circle. No curves, okay, or loops. So that's why these are not polygons, because they all have a curve. Now, closed figure means that all of the vertexes, the corners, that they meet and they close. There's nothing open, all right? Now, you'll also hear, with polygons, and make sure you write this down, regular versus irregular. So regular means that they have all the same side length and same angle, okay? Irregular means the side lengths and the angles are all different, okay? So it might be a 5-sided figure, but the side lengths and angles aren't all the same. Where if we look at this one here, this pentagon right here, looks pretty much like it would be a regular polygon. So that means that all of those angles are the same and the side lengths same. All right, let's keep it rolling here. We've got a lot to do. So I want you to pause this video and do these. We'll do the first one of these together, so let's do that now. Okay, so I have y equals half x minus 3. X is equal to -2, they tell me. So we're going to go ahead and put in that -2 for x. So we have 1/2 times -2, because that was the value of x, minus 3. So here we ended up with -2 over 2, which gives me -1 minus 3. So we're good Minnesotans here. Think of -1. It's -1 degrees. It's going to go down -3 more degrees. What will it be at? That's right. It's -4 degrees. Or you can also think of that as -1 plus a -3. And the reason it's plus a -3 is because you're adding negatives. Okay. You can also think of it as debt. I owed someone $1. I owe them $3 more. I now owe them $4. I'm in the hole. I'm at a negative. I like to think of temperatures. You do what you want to do. So let's go ahead and do 2 through 6 in your notebook, just to practice supplementing in that value for x and solving the equation. I'll have answers for you in just a second. So here are your answers to those 6 problems. I hope that you were successful with those. I think they're good. That's just good practice for us. My guess is we haven't worked a lot with the negatives, and we will be coming back to that. So, all right, let's move on. So take a second, pause the video, and draw these 5 shapes. All right, so these shapes are all regular polygons, okay? And they are polygons because they're closed figures, and they are 3 or more sides. And what I want us to do is I want us to really think about this fundamental question is, how do we find the interior angle sum? So that's all of the angles inside the figure added up together, okay? And remember, interior angle sum is just what I said it is, sum of all the different angles inside that figure. Please include that in your notebook, that definition, interior angle sum. Pause the video and write that in. So now that we have those 5 shapes drawn in, I want us to look at these first 3. So the first one is a triangle. We already knew that that had 180 degrees, and that triangle is it's like the key to unlock all the other shapes. So we have to know that one, as I've said in previous videos. The next one, the square, is 4 sides, and if we cut that right down the middle from one vertice to the other, and when we start cutting these, we always start at the same vertice and we draw as many triangles as we can. So someone might argue that, well, wait a minute, we could draw a lot more. We could draw more because we could cut it this way, but then we'd be overlapping. Okay, so we can't cut them into smaller triangles because then it would be infinite number of triangles. So just start at one vertice and always stay from that vertice and draw as many triangles as you can. So in doing that with the square, we end up with 2 triangles, and each of those triangles is 180 degrees. So we could say that inside the square, there are 360 degrees of measure, which if you think about it, each of these corners right here is a 90 degree. 90 times 4 is 360. So there's another way to prove that that's correct. All right, here we have another 4-sided shape. Okay, and this one again has 2 triangles, and so we know that each of these triangles has 180 degrees of measure. So this 4-sided shape has 360 degrees of measure. Now if we continue down here, now we have 5 sides, and we have 3 triangles. Okay, so when we had 4 sides, we had 2 triangles, and now we have 5 sides and we have 3 triangles. Note that I started here at that vertex and I drew all my triangles out. So I have 1, 2, 3 triangles. Those 3 triangles, now we could say that figure has 540 degrees of interior angles sum, the angles inside. Now we could also then take that 540 and we could divide it by 5 because there are 5 angles, and then we could say that each angle inside then has 108 degrees of measure. All right, don't worry about that so much. Just worry right now about the interior angle sum. So the last figure here that I've got is the octagon, 8-sided figure, and it has 6 triangles. So again, I started here at that same vertice and I drew out all of my triangles, and I just drew to the other vertex. Okay, and so in doing so, I get 6 triangles. So you might see, you see my question at the bottom, is there a pattern? So is there a pattern here? We had 4 sides, 2 triangles, 5 sides, 3 triangles. Then we jump to 8 sides and we have 6 triangles. Is there a pattern? If we had a 6-sided figure, how many triangles would we have? We'd have 4. So is there a pattern? There might be. Let's continue on and see if we can find that. So what I want you to do right now to find if there is a pattern or not is I want you to do page 211 and 212, or at least that's what I'm calling it in my book. It'll say angles of polygons, and it'll say 3.3 on it. And it should look like this. And I want you to just do this chart here at the top of 212. All right, and then come back to the video when you have that done. All right, so you just completed that chart, and you should be able to absolutely whip through this like in no time at all. So, and you've already seen some of these angles from me. So use triangles to find the sum of the interior angles measure on the polygons, on these polygons. Pause the video, draw it out, or just write it down, whatever you want to do, or use that chart. I'll see you in a second. So here's what you should have come up with. This four-sided figure has 360, okay? This one has 1080 degrees of interior measurement. This one has 720, okay, and that's that six-sided figure. The 4 still has 360, the triangle has 180, and here we back to the pentagon, five-sided, it's 540. All right. All right, let's move on. So really, in your warm-up, if you've done your warm-up and your plus journal pages, you probably have come up with some kind of formula or some kind of idea. All right? And in coming up with that idea, we really look at, well, when we have a triangle, three-sided, we have one triangle. With four-sided, we had two triangles. 5, we had 3. 6, we have 4. So here's our formula. The sum, S, of the angle measures of a polygon with n sides, the formula is S equals n minus 2 times 180. So the n is the number of sides, okay? S is just to find that interior angle sum, okay? So please take a minute and copy that formula down because we're going to be using it in the rest of this lesson. All right, so now that you've copied that formula down, find the sum of the interior angles measure of this school crossing sign. Now, again, we can continue to divide these into triangles and say, okay, it's 180 times 3, it's 540. We've got that on our chart. But now let's use the formula, okay? Let's practice using that. So that formula is going to look like this. The formula, and remember, write those formulas down because then you can just plug in your numbers. So it's S equals n minus 2 times 180. And then it's the quantity of 5 minus 2 times 180. So again, that 5, we substitute 5 for n. That's the number of sides. We're going to subtract 2 from that because that will give us the number of triangles really that are in that side, that figure. And then when we multiply 3 times 180, we get 540 degrees. Now you've already worked with that pentagon many times. So you should be knowing 5 sides, 540. All right, let's keep moving. So here we have our six-sided figure, this polygon, okay, hexagon is its name. I want you to go ahead and find the interior angles measure of the polygon. Pause the video, be right back with you. So here's what that work looks like. And I love that this is what I have to do. I have to at least mark where I start counting the sides, or I totally forget. But I've got a six-sided figure, so I'm going to write out my formula. 6 minus 2, okay, and times 180, so that gives me 4 times 180. So this six-sided figure, this hexagon, and it's a regular hexagon, or at least I'm assuming so, that's 720 degrees of measure, okay? Now, let's see if we can do these two more. So find the sum of the interior angles measure of the green polygon. So you might be saying, well, wait a minute, those aren't even polygons. Yes, they are. These are straight lines up here, and these are straight lines. And this, by the way, is a honeycomb, and that's where we get that hexagon from. So go ahead, pause the video again, and do these two problems. So here's our answer. We have this. Is this seven-sided? 1, 2, 3, 4, 5, 6. Seven-sided figure is 900 degrees of measure, and this six-sided figure is 720 degrees of measure. All right. Now, that is about where I'm going to leave it for now. You're going to watch a second video in just a few minutes, and we're going to talk about taking this lesson a little farther. So, thank you for tuning in. I'll see you for part 2 in just a few minutes.